Dear students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn the null and alternative hypothesis, the random sampling distribution of the difference between two sample means. Let us look at the learning objectives. The first objective is understand the concept of null hypothesis and alternative hypothesis, random sampling distribution from normal parent population. The next, the students are able to understand the concepts of obtaining the test statistic for the difference between two means by describing the mean difference and standard error of mean differences. Let us start. We begin with the first part of the lesson, in which you will learn the null hypothesis and alternative hypothesis. The null hypothesis and alternative hypothesis are two fundamental components of hypothesis testing. They represent different claims or statements about the population being studied. The null hypothesis states that there is no significant difference between the means of the two populations from which the samples are drawn. It assumes that any observed difference between the sample means is due to random chance or sampling variability. Null hypothesis. In statistical notation, the null hypothesis is usually expressed as a statement of equality, such as H naught from mu1 is equal to mu2, that is population means are equal. H naught from p is equal to 0.5, that is proportion is equal to the specific value, and H naught from beta is equal to 0 is nothing but regression coefficient is 0. The purpose of hypothesis testing is to assess the evidence against the null hypothesis and determine if there is enough statistical support to reject it in favor of the alternative hypothesis. If you look at this figure, there is a original curve and this is a resampled curve. Then we have a type 1 error alpha 1, type 2 error alpha 2, and power of the test are represented in this figure. This is the decision threshold about the parameter theta. Alternative hypothesis. Alternative hypothesis is the claim or hypothesis that contradicts or challenges the null hypothesis. It represents the researcher's alternative explanation, expectation, or theory about the population. The alternative hypothesis can take different forms depending on the research question and the specific situation being studied. It is often denoted as a H1 or H alpha. The alternative hypothesis can be one-sided or two-sided. It is also called one-tailed test or two-tailed test depending on the research question. One-sided alternative hypothesis, it is nothing but one-tailed test. A one-tailed alternative hypothesis specifies a specific direction of the effect, difference, or relationship. It indicates that the observed effect will be either greater or less than the null hypothesis value. For example, if you consider H1 from mu1 greater than mu2, that is population mean of group 1 is greater than the population mean of group 2. Two-sided alternative hypothesis, it is also called a two-tailed test. A two-sided alternative hypothesis does not specify a specific direction of the effect, difference, or relationship. It suggests that the observed effect will be different from the null hypothesis value, but it does not specify whether it will be greater or smaller. For example, we consider H1 from mu1 is not equal to mu2, that is population mean of a group 1 is different from the population mean of a group 2. The choice between a one-sided or two-sided alternative hypothesis depends on the research question, prior knowledge, and the directionality of the effect under investigation. Two-sided alternative hypothesis. We consider H1 from mu1 minus mu2 is not equal to 0. This is nothing but two-tailed alternative hypothesis. We consider H1 from mu1 minus mu2 if it is greater than 0. This is one-tailed alternative upper tail, and H1 from mu1 minus mu2 if it is less than 0, it is called one-tailed alternative hypothesis and also lower tail. In these alternative hypotheses, mu1 and mu2 represent the population means of the two groups being compared, and the symbols is not equal to, greater than and less than denote the specific direction of the difference between means. If you look at this figure, the first curve represents right tail test. Similarly, the second curve represents left tail test. Then third curve represents two tail test. In the first curve, the rejection region is right side. The second curve, the rejection region is left side. In the third curve, the rejection regions on both sides, that is level of significance alpha by 2. Example, a company wants to compare the effectiveness of two different training programs on employees' productivity. They randomly select two groups of employees. Group A receives training program 1 and group B receives training program 2. After the training period, the company measures the productivity levels of both groups. The goal is to determine if there is a significant difference in productivity between the two training programs. We can define null hypothesis H0 for this example. The null hypothesis states that there is no significant difference in the mean productivity levels between the two training programs. It assumes that any observed difference in sample means is due to random chance. In this case, the null hypothesis can be expressed as H0 from mu1 minus mu2 is equal to 0, where mu1 represents the mean productivity level of the employees who received training program 1 and mu2 represents the mean productivity level of employees who received training program 2. The null hypothesis assumes that there is no difference in the population means of two groups. We can define alternative hypothesis for this example. The alternative hypothesis challenges the null hypothesis and suggests that there is a significant difference in the mean productivity levels between the two training programs. It posits that the observed difference in the sample means is not merely due to chance, but represents an actual difference in the population means. The alternative hypothesis can be expressed as a H1 from mu1 minus mu2 is not equal to 0. In this case, the alternative hypothesis states that the mean productivity levels of the two groups are different. It is a two-tailed alternative hypothesis, allowing for the possibility of a difference in either direction. Dear students, let us summarize what we have learnt in the first part of this lesson. That is, we are discussed elaborately about the null hypothesis and the alternate hypothesis with suitable examples. I hope you understood all the concepts. We will continue in the next video. Thank you.